Hi everyone, it's me, Mrs. Louderback, and going to walk you through the lesson. So one of the things that we're going to do today is review geologic processes, complete slides 18 through 26, and then you'll have a quiz later next week that you'll want to prep for. So one of the things that I first wanted to look at is compare, looking at the channel here. All right, so here's that channel on Mars. What your initial thoughts were on what created this channel. Was it flowing water that formed the channel or flowing lava? Most of the classes were pretty split 50-50, so it was fun to see your insight and to look into it. But now we're going to look a little closer at the differences between flowing lava and flowing water. So we're going to open up our notebook. And first is a little bit review of looking at the cards from the previous day. So for the most part, we noticed that when it comes to flowing lava or flowing water, okay, by looking at the cards, some of the landforms were curved, branching, while other images showed that the water flowing through the surface created little ridges, especially on drier climates. All right. When we looked at the flowing lava, we see that most of the landforms were straight with only small curves. Then the landforms were wider than the flowing water. Okay, so we see a lot of variation with flowing water than we do with flowing lava. On top of that, when it comes to your own observation and question, I'm going to leave that up to you and look through that. Ultimately, we're kind of trying to decide what geologic process could have formed this channel right here. So we're going to do a little bit more investigation today. And we're going to be looking at the investigation through using models as tools. All right. So getting a little presentation here. Just like Garay was trying to get evidence about the geologic process that formed the novae on Venus, we have a similar question today in terms of what formed the channel. So one of the challenges in studying the channel on Mars is that Mars is too far away for scientists to directly observe what happens there. So how can we study a planet that's too far away for you to directly observe? In this next section, we're going to learn about models and how scientists use them to gather evidence about things that are otherwise difficult to study. To help us figure out whether liquid water on Mars in the past could have formed the channel on Mars, we've already compared the shape of the channel to channels on Earth where it is currently flowing. Comparing the dry channel on Mars to the current water-filled channels on Earth is only helpful if the landforms that are flowing water remain after the water stops flowing. So our question today, well, one of our questions is, do the landforms made by flowing water remain after the water stops flowing? So if I were to stop the water on this creek here, would the remaining landform still be there, or would it possibly collapse? So here is our stream table today, okay? So this is parts of our model. So here, when we're looking at parts of the model, we've got a bucket, a hose, some books to stack up our tray on, and our tray is filled with sand. And inside the bucket is water that's going to come through the hose and spill on the sand, okay? Now the sand represents land, or the geosphere. And the water will represent the rivers and streams, which is part of the hydrosphere. So when it comes to what we think the model will show is we're hoping that this little miniature model here will have flowing water and it'll create a channel landform in the sand. All right, so here we've got a model of flowing water footage and a video of an aerial footage of a creek bed in real life. So let's watch the model from in class first. Okay, and then now let's watch the aerial view of a river. All right, so now in this slide 21, okay, we've got our model here. I'd like you to answer these three questions. How is the flowing water model similar to flowing water on Earth? So how is this model here similar to the second video we saw on the slide of water flowing in a river or stream on Earth? How is the flowing water model different from the flowing water on Earth? And then how would you make this model, this image on the left here, more like the actual geologic process that we would see on Earth? What things would you add to make this more realistic? All right. So I would recommend you pause this video and answer the three questions before moving on. All right, now it's time to research the connection between geologic landforms created by flowing lava. So on some rocky planets, volcanic activity causes lava, hot liquid rock, to erupt from underground and flow over the surface. Evidence of this process can include canyons carved by flowing lava and certain types of igneous rock formed by when lava cools rapidly. Okay, I want to really stress that lava is hot liquid rock. Okay, so this moving through like a liquid, I mean, it is a liquid, is rock. All right. So our question is, how do landforms made by flowing lava compare with flowing water? All right. So we're going to have a similar modeling tool today. All right. But the difference, we're going to have all the same parts. The only difference is instead of water, we're going to use hot wax, and the hot wax will represent lava. So when we're looking at the geologic processes, the sand will still represent the land, which is the geosphere, and the hot wax, which represents flowing lava. If you remember from the previous slide, flowing lava is liquid rock, and rock is part of the geosphere. So this whole model is just showing changes in the geosphere. There's no other sphere or system interacting in this model. So what do we think this model will show? Well, we either want to see a channel form as well, like in the water, or we hope to see a channel that's different or a different landform created. So just like before, we've got two videos, one that's going to show the flowing lava model, and then one that's going to show lava flowing in real life.
This is a tilted tub of sand that represents a sloped hill. In a moment, hot wax will pour from the blue water bottle to move along.
Okay, and now we're going to watch the flowing lava in real life from this National Geographic video. So just like before, you're going to answer these three questions. How is the flowing lava model similar to flowing lava on Earth? So how does this model in the image on the left similar to the video we watched of the National Geographic just recently? How does the flowing lava model different from the flowing lava on Earth? And then what could you do to try to make this model a little bit more realistic? Okay, what can we add here to create a more realistic model in terms of flowing lava creating a channel? So what I'd like you to do is take a moment to pause this video and answer the three questions on this slide. Okay, now the last thing that we're going to do today is answer slide 26. So our ultimate question is, what geologic process could have formed this channel on Mars? Was it flowing water that formed the channel on Mars, or flowing lava? Look at the two images, think back to what evidence may have formed this channel right here. And then I'd like you to state the claim by rewriting the full sentence. Flowing lava formed the channel on Mars, or flowing water formed the channel on Mars, and then your reasoning why. This should be a good supportive evidence. After that, that is it for the lesson in our slides. You should have slides 1 through 26 done. And if you have any questions at all, please make sure you reach out to me, Mrs. Lauterbach, and I'll try to clarify any of the responses. Bye.